Welcome again, and now we will do trigonometric substitution. So the first thing is to recognize whether we can use trigonometric substitution. So anytime you see a square root, that should tip you off that there's something there that has to do with the right triangle. So to help us here, I have on the left side Pythagorean theorem, trig functions, inverse trig functions, trig identities, derivatives of trig functions. And on the right side, I have a little algorithm that gives us procedure what to do. First, we set up our right triangle, change variables in terms of theta, in terms of angle. Then we substitute variables. We express everything in terms of theta. In this case, it will be x, and then back substitute. So first of all, let's set up our triangle. We need to find some expression that looks familiar to our denominator that's under that's under the square root. So something that looks familiar with 9 minus x squared. If you think about this, there's a big number and you're subtracting a smaller number from the big number. Well, what's the biggest number or biggest value in a right triangle? Well, hypotenuse, of course. So obviously, when you compare this expression, you know that you're subtracting hypotenuse. So in this case, hypotenuse is 9. I'm sorry, the square root of hypotenuse is 9. So c squared equals 9. Therefore, hypotenuse will equal 3. Sorry. Will equal 3. Now we can choose, so one of the sides will also square of one of the sides will be x squared. So one of the sides we can choose to be simply x, which will be this side. So let's check if we're correct. If we are correct by Pythagorean theorem, the green side or the adjacent side of this triangle should be hypotenuse squared, which is 9, minus opposite side squared, which is x squared. So let's look. Yes, that's what we have, 9 minus x squared. So that is the first step to set up the triangle to look something like our problem. Next thing that we would like to do is to express our variable x in terms of the angle theta. So by using our trigonometric functions or definitions of trigonometric functions, I will choose sine. Sine functions or sine theta is defined as opposite sides, as the ratio of the opposite side and hypotenuse. So in this case, it's x divided by 3. Now we need, since we need our dx, which is derivative of x, we first need to get x by itself. So from this here implies that x equals 3 times sine theta. Well, now we need the dx. So we need to do the derivative of the both sides. So we need to do the dx d theta. So our dx d theta will be derivative of 3 sine theta. So let's see what it is. Now remember the product rule for derivation is if you have say a times b prime, you want to it's the derivative of the first times the second plus first times derivative of the second. In our case, the first term is a. In our case, a is 3 times another part is sine theta. Sine theta would be b. So derivative of the first, so derivative of the 3 is 0 times the second, which is sine, is 0, plus first, it's 3, times derivative of the second. Derivative of sine theta is cosine theta. If you forget, it's here. So we get that the dx d theta is 3 cosine theta. Let me erase this so it's visible more. And now from this derivation, we still need to express dx in terms of theta. So dx is now 3 cosine theta d theta. Now what we're going to do is rewrite our integral, and instead of dx, we already expressed it in terms of theta, so we'll just put the whole thing here. So this is our dx expressed. We've changed the variables, so now it's d theta in terms of theta. So let me change the color accordingly. Now we have a little problem here. Everything must be in terms of the same variable, so we cannot have mixed thetas and x's, which brings us to the next step, which is to substitute variables. Substitute everything. Where you see x, you need to have it in terms of theta. Again, it's useful to use our triangle and what we know about trigonometric functions. So we need this side, which is adjacent side, to be at the bottom. So we either need x divided by square root of 9 minus x squared, or 3 divided by square root of 9 minus x squared. So this will 3 divided by 9 minus x squared will be obvious choice, because we can rewrite that as 3 times our fraction here, which is 1 over 9 minus x squared. And now only, so we have this relationship, but let's see what it is, which trigonometric function it is. So we're saying it's a 3 divided, so it's hypotenuse divided by adjacent. So let's look here. Alright, so hypotenuse h divided by a, so that's secant. So this equals secant theta. So if that equals secant theta, then so 3 times, so this whole thing, 3 times this whole thing equals secant theta. We only want our fraction, so we could substitute that into here. So our fraction will be, so 1 divided by 9 minus x squared will multiply by 3, will just be 1/3 secant theta. And well, we can actually just take that, and I'm going to copy it, and just, so now we're going to substitute this and rewrite it in terms of theta. Okay, so we have this. Now we can cancel some things. We can cancel number 3 here and 3 here, which leaves us with the following integral. It's integral of, integral of secant theta times cosine theta d theta. But as we've seen before, secant and cosine are really inverse functions. So secant is really 1 over cosine theta times cosine theta d theta. Well, that'll just be integral of 1 d theta, and in terms of theta, the solution is 1 theta. And now the last step is back substitute. So what is 1 theta? We're going to use again the trigonometric relationship that we set up in the step number 2, where we said that sine theta equals x divided by 3. So let's use that relationship. So if sine theta equals x divided by 3, then what we need to do to get theta to extract is do the arc sine operation. So theta, if we want to get theta alone, we need to do the arc sine of the result. So theta is arc sine of x divided by 3. So our answer is arc sine of x divided by 3, and since this is indefinite integral, we don't forget our constant, and that is your answer for this. So that's 10 minutes. Let's see if we can check the answer to see if we did integral correctly. So let's pause now. Now we need to use a chain rule here, so do the derivative of arc sine of x over 3, and it's just from our derivative table. Derivative of arc sine, so arc sine of x prime is defined as 1 over 1 minus x squared, or at least that's what I remember. Let me see, let's check, make sure. Yeah, it's 1 over square root of 1 minus x squared. Okay, so in this case we will apply that, so that will be 1 divided by 1 minus x divided by 3, all of that squared. So that would be derivative of our outside function evaluated by the inside times the derivative of 1/3 x, which will be just 1/3. So let's simplify this. So it's 1 divided by 1 minus x squared divided by 9 times 1/3, so it's 1 over 3 square of 9 minus x squared divided by 9, which is just some tedious simplification right now. So we have 3 times this. We could express this as square root of 9. Therefore, it's 1 over 3 times 9 minus x squared 3. We can cancel the 3's, and we got back our original problem, so that makes sure that we integrated correctly. Alright, thank you. That's all for today.